So you work hard in order to get good grade in the exam. Okay, at least pass.
Next year come again.
And I do not want to see you next year. Okay? I don't want to.
Okay. Remember his face.
Okay. Today we are talking about first one is the continuity equation. Continuity equation tells you Q equals to A B. A indicates the cross-sectional area.
Then morning I think I'm
Unit is meter square.
go
B is the velocity. Unit is meter per second. Q indicates the volumetric flow rate, which is meter cube per second. Alright? So in thermodynamics, what we learn? There is a control volume, right?
Yes.
In the control volume, the fluid is flowing, and we can write down the mass conservation equations. This is the control volume, and mass is flowing. This is in, this is out, right? M dot in, M dot out, right? This is the CV. In the CV, dm by dt, right? This changed or dm by dt doesn't change, anything may happen, right? So you can see, we can write mass conservation tells me dm by dt is equivalent to what? M dot I minus M dot O. Remember, right? Then after that we can write, I think you better use the simple method. No need to go to the complex. Okay, so what is M? What is M? M is defined by rho times volume, correct? Rho times volume. So what I can write here? I can write d rho p, right? Volume by dt, correct? Is equivalent to, what is m dot? Rho times volumetric flow rate, right? The volumetric flow rate, I can write rho times q. Or in thermodynamics we write this one is v dot, right? You remember, v dot is q. Then what is q? Q becomes area times velocity, correct? So I can write rho v, this is rho what?
V.
AI velocity vi, correct? Minus rho A outlet cross-sectional area velocity at the outlet. Okay? We can write this. So this is true for incompressible fluid. So for under steady state, steady flow, we can write under steady state, steady flow, we can write dm by dt equals to 0, right? M dot I, M dot O. I can write, no problem. So this is true under steady state. Okay? Then what is Mi? Rho AI, Vi, rho A outlet, V outlet, right? I can write AI, Vi is equivalent to AO, VO. Correct? I can write. Right? This is true. So from that concept, I can write two equations, right? You see the summation of mass flow rate at the inlet is equivalent to some, because maybe there may be, two inlet, one outlet. Correct? Then what would be? Here is one, here is one, here is outlet. Correct? So that's why the summation of total inlet at the mass flow rate at the inlet is equivalent to summation of total mass flow rate at the outlet. This is number 1. Number 2 tells me the summation of volume flow rate at the inlet is equivalent to summation of total volume flow rate at the outlet are same. Okay? This is true for incompressible fluid or liquid. Okay, so this is number 1 equations and this is number 2 equations. There are 2 equations. One, I am using this equation, that's all. Okay? And another equation is this one. D rho B by dt, rho AI Vi minus rho AO VO. This is another equation. Okay, so now I am going to show you the tutorial questions and how to solve them. So first question is oil having a specific gravity of 0.9. Oil is here. Oil is flowing this direction. Its specific gravity is 0.9. This oil is pumped, okay, into this system and mixed with water. So water is flowing this direction. So water Q1. Okay. The water flow rate is 2 meter cube per second. Is given. Meter cube per second is 2 for water. The water and oil is mixes at that position, right? And finally, the mixture is the exit fluid. And the specific gravity of that fluid is 0.95. Okay? That means the density is different, right? Different specific gravity means different density. Now they tell you calculate the flow rate of oil. What is the oil flow rate? I say this is Q2. So this one I say Q3. Okay, they tell you what is the value of volumetric flow rate of Q2. How to find Q2? What is the basic equation? What is the summation of this equation, right? I tell you, summation of mass flow rate at inlet is equivalent to summation of mass flow rate at outlet. Correct? Right. So what I can write from there? From there I can write m dot 1, right? Plus m dot 2 is equivalent to m dot 3. Can I write this? You agree? No problem. Secondly, what is m dot 1? M means rho times q, right? So I can write rho 1, q1 plus rho 2, q2 equivalent to rho 3, q3. Correct?
Yes.
What is the rho? Rho indicates the density of water times specific gravity, right? So I can write what is the specific gravity at 1? 0.9, right? Then I can write 0.9 times density of water, right? Times Q1 plus what is rho 2? This is 1, right? This is water. Oh, this is
one is water.
Q2, right? So Q1, rho 1 is density, specific gravity is 1, right? Here is 0.9 times rho of W times Q2 is equivalent to 0.95 times rho of W times Q2. Sorry, Q3, right? Then what I can write? So this one I can cancel, right? This one I can cancel. Then I can write Q1 plus 0.9 Q2 plus 0.95 Q3. Can I write this? No problem, right? So Q1, what is the value of Q1?
2.
Q1 is 2, so I can write 2 plus 0.9 Q2 plus 0.95 Q3, right? I can write this, no problem. So what is the another equation? You remember? I show you two equations. One is mass flow rate at inlet and mass flow rate at outlet are same. Similarly, the volume flow rate at inlet and volume flow rate at outlet are same. Now what I can write? Secondly, I can write
Q1
the
plus
volume
Q2.
flow rate at inlet, volume flow rate at outlet are same, right? Then I can write Q1 plus Q2 equivalent to Q3, right? Right? Now I can substitute. So this value I can put here. Then problem is solved. Now this question is very easy, okay? An exam question is not like this. But you have to understand, right? How to employ the mass balance and the volumetric flow rate balance between the inlet and outlet. Okay, so now, okay, I show you another interesting phenomena. This indicates the cross-sectional area at section 1. This indicates the cross-sectional area at section 2. And this indicates the cross-sectional area at section 3. This is another concept. If I tell you how to find the velocity, when you know the volumetric flow rate, then you know the area which should be given, then you can find the velocity. Because Q becomes area times velocity. Okay? So now I show you, I get here like this, right? 2 plus 0.9 Q2 plus 0.95 Q1 plus Q2, 2 plus 0.9 Q2, then 0.95 times 2, right? Q1 is 2, 0.95 Q2, right? Then after that I get 0.1, right? 2 minus 0.95 times 2 is equivalent to 0.05 Q2, right? Then 0.05 Q2 is equivalent to 0.1, so Q2 becomes 2 meter cube hours. Okay? Alright, now this is the answer. If I tell you find the velocity at section 2, V2, then you can write 2 becomes area at section 2, velocity at section 2, right? Then area should be given to you. Then you can find the value of V2. Alright? From there you can find V2 becomes 2 by area square meter per second. Alright. So the second question, a hypodermic syringe is used to apply a vaccine as shown in this figure. If the plunger is moved forward, okay? If the plunger is, this is the plunger, right? So this is moving forward. Push, right? It is moving forward. So what happens? So this indicates the control volume, right? Right. And the control volume here is not fixed, right? It is deformed. So this control volume is deformed here. This is deformed, right? So what you can write? If the plunger is moved forward at a steady flow rate of 20 millimeter per second, that means its velocity is 20 millimeter per second. So this one is, I said this is V1, right? Whatever, right? So this value is plunger P is 20 millimeter per second. Is given. If the vaccine leaks past the plunger at 0.1 of the volume flow rate out of the needle opening. So that means we understand that the fluid goes out from the syringe, right? Through the axle. And this value I said Q out, right? This value is Q out. And this indicates Q leak. Right? It tells you that Q leak is equivalent to 0.1, right? 0.1 of Q out. According to the question, I can write it, right? Calculate the average velocity at the needle exit. So they tell you what is the velocity at the needle exit, V2. In that case, you can see that the inside diameters of the syringe, that means the inside diameter of the syringe from here to here is 20 millimeter. This value is 20 millimeter, and at the needle, this value is 0.7 millimeter. Right? Then here what I should do? I should do the mass balance, right? Correct. What is the total mass? Total mass is here. Right? Total mass. I put lot of water inside the syringe. This indicates the total mass of the fluid inside the syringe, right? So I can write, this is a common sense, right? I can write total fluid in the syringe, MT. Right? Is equivalent to, right? How much fluid goes out from the syringe? This value plus total mass there. Then I can write MT is total mass at the outlet. I say O plus total mass leak. Correct. Then I can write, from there I can write M dot T is equivalent to M dot O plus
Have already already.
M dot leak.
现在有了。I think they just
I can write this, right? No problem. Yes or no? Mass balance tells me
比较大，应
I
该
can do
900
this.
1000。
And from there I can write same fluid, is it? Same or different fluid? Same fluid. Then I can write Q total, right? Is equivalent to Q at the outlet, right? Plus Q leak. Am I right?
Yes.
Then what is the value of Q leak? 0.1 Q out, right? Then I can write this becomes 1.1 what? Q out. Done. Very simple question, right? Then what I got? I got here. You remember, right? In the syringe, something like this. Right? Okay, something like this, right? So here is the velocity of the plunger. P, I can write, show you, and this indicates the control volume, whatever. And here is the leak. This is the Q out, right? Q out.
开开啊，可以，我只要开啊，开车了。
Right. Then I can find Q dot total equivalent to 1.1 cube outlet. So here is 20 millimeter, right? G1,
cut
I
same
write
hairstyle.
here, G2. And what I can write?
cut same hairstyle.
What is the Q dot T? Q2 becomes
你看我可以试一个
area
Huh?
at 1 times the velocity of the plant
pineapple.
is equivalent to
But then how you
1.1
measure?
outlet
I got
area
this.
and velocity at the exit. And you have to find the value of this velocity. This is I am going to find. Then what I can write? Area 1 by area outlet times velocity of the plunger 1.1 is equivalent to VO, right? Then VO becomes, what is area 1? Pi by 4 times, what is the diameter? I also forget, right? 20
20.
millimeter square. Right. This is pi by 4, 0.7, right? 0.7 square times, this is 20, right?
What are they doing, sir?
20 millimeter per second.
Cell liao, exam
And
coming
this
cell
one is
liao.
1.1, right? Unit is millimeter per second. Right. Then after that you cancel everything and finally I get here 14.84 times 10 power 3 millimeter per second, or you can write 14.84 meter per second. Alright?
我在追，我看印度来电话讲，他说住什么？
I do the mass balance on
在
total
那
mass.
个美国他讲，
Okay? It's nothing new.
你啊，对对对，他到他站了，他站起来，那种那旁边不在一个省会，跟那个老人家做的。
Okay.
那
This question
那个 trace
try to understand. This is quite
他
complicated.
我在那个
Oil is flowing downward through the vertical pipes.
哇，因为他们有
Oil is flowing downward through the vertical pipes. And the pipe's diameter is different, right? At the inlet and the other. That is 300 millimeter diameter at the top, and there is 100 millimeter. If the mercury
有人去按那个 immediately stop。
manometer reading H, right? Which is 100 mm. Determine the volume flow rate for frictionless flow. They tell you calculate Q, volume flow rate. This is question 1. Determine the volume flow rate for frictionless flow. Second question. Is the actual flow rate more or less than the frictionless value? Explain. Two questions, right? First case, actually, all our equations that we wrote here are valid for frictionless flow. For ideal case, they are okay. For real case, these are not okay. You have to add the friction head. Later I will show you. So, first question is, you have to calculate the value of Q. Right? What I can do? I can choose one point here, right? And I can choose another point. So I write this is 1, this is 2. So what is the value of Q? Tell me. Q should be A1 V1 equivalent to A2 V2. Correct? No problem. So A1 I can calculate easily. No problem, right? So what is the value of A1? Pi by 4 times diameter is 300 mm, right? A2 pi by 4 100 square, right? Unit is millimeter square, not meter. If you do meter, it should be 0.3, this should be 0.1. This is the difference. Then what I can write? From there I can write A1, B1 equivalent to
A2
A2, V2.
V2
Then V2 becomes, or V1, never mind. V1 becomes A2 by A1 times V2, right? What is A1? A2, can I write this way?
Okay.
No problem, right?
Mm.
I can write. So now you remember,
Yes.
I have written V1 is this value. Okay. Okay, now how you can calculate Q? Okay, V1 I calculate, right? From there. But A2 I know, right? So how you can calculate V1 or V2? Right, I do not know how to calculate it. Then which method you should apply? You have to apply the Bernoulli's equation between 1 and 2. Otherwise you cannot solve. Okay?
Yes.
So now I am applying Bernoulli's equation between 1 and 2. Applying Bernoulli's equation between 1 and 2. Then you can see this is the oil, right? Between 1 and 2. I write here. So what we can write? Tell me. P1 by rho G, right? And V1 square by 2G plus Z1 is equivalent to P2 by rho G plus V2 square by 2G plus Z2. Right?
Yes.
So now what we can write? Can I write like this?
Sure.
P1 minus P2 by rho G. No problem,
How you
right?
drive car?
Then
How you
it's
drive car?
equivalent to
Waste fuel.
V2 square minus V1
Very
square
raining morning.
by
Got where?
2G
Yeah.
plus
Sure you did
Z2
for them.
minus Z1. Right,
My
what
bike
is
also got
this?
shelter.
Z2 minus Z1?
My bike also got shelter.
Z2 is here, right?
Highway got
I put the
shelter.
reference point here. Z2 is here, 0, right? Z1 is here.
Yes.
So Z2 minus Z1 is minus 6.
Point
So
six.
Z1 minus Z2 plus 6. So in that case, I choose this one as a reference point.
0.6.
Okay?
Yeah.
Then I can write, I am going to find the value of V1. And my target is to find V1. This is my target. Then I can write V2 square minus V1 square by 2G is equivalent to, tell me, P1 minus P2 by rho G plus Z1 minus Z2, right? Which is
0.6.
this one. Because here is Z2, here is Z1. That means plus means Z1 minus Z2, which is 0.6. So this is another equations. How many equations? 2 equations, right? Previous one I wrote 1, now is another. Now I am going to find the value of P1 minus P2, correct?
Yes.
When I get the value of P1 and P2, I substitute here, problem is solved. Done. Now, how you can find P1 minus P2? By, from the manometer. Here is P1, here is P2, right? The traveling method. Done. I can write P1 plus rho GH oil times 0.6, correct? Plus rho GH x plus the distance from here to here is h, which is 100 millimeter in the question. So I can write the distance from here to here. Then from here to here, negative, right? rho GH of, what is rho? Rho is mercury. Then here, right, is equivalent to P2. Now I can write, to take a look. From here to here is 0.6, from here to here is x plus h, I write, right? H is given 100, and from here to here is h, and from here to here is x, correct? And here is P1, here is P2. Then what I can write? Tell me. From the manometer, I can write P1 plus, right? Rho G H. H is 0.6 plus x plus h. Correct. Minus, what is rho GH, right? What is this one now? Tell me. This is
Mercury.
rho of what?
Mercury.
Rho of mercury. Yes. What I guess. Now it's coming. Yeah. Rho of mercury.
Very funny.
Times
Okay, like the guy in the class keep laughing, don't know for.
times h
Why not?
minus rho of oil G times x, negative, right? Is equivalent to P2, right? Good. Then what I can write? Tell me. Now I can write P1 minus P2. No problem, right? Is equivalent to, I put it that side. Then here you can see, right? So this is negative, right? So this one I can cancel, right? No problem. X cancel. Then P1 minus P2 I write rho Hg, right? Is positive. G H. Correct. Minus rho G minus is this is minus, right? 0.6 plus h, right? What is the value of h?
100 mm.
Yeah, I write here h, no problem. Then here is rho g, right? I divided both sides by rho g. P1 minus P2 by rho g. Correct. Is equivalent to rho Hg G H by rho G. Correct. Minus 0.6 minus H. Right? Then what I can write? Because I want to calculate this number. I don't want to, I make it like this. P1 minus P2 by rho G, correct, plus 0.6 is equivalent to what? H common rho Hg times G rho G minus 1. Okay? Yes or no? Correct.
So how come become plus H then already become minus H?
This one is here, this one is coming here. So this one is H common. So this one minus 1.
So I mean before that step is 0.6 plus H, then after that you 0.6.
Yeah, this is minus times plus minus. I think I correct, right? So now I do some training, right? I can write, what is H? H is common. What is this? Tell me. 13.6, right? Times rho of water times G. And here is 0.6. What is the density of oil?
0.9
Another question. 0.9. Yeah.
Oh, smart.
0.9
Can we pass me?
times rho W
Hey,
times
student.
G minus 1, right? So cancel, right? So H is 0.1. Correct. Then I write here so that you can visualize. I can write P1 minus P2 G plus 0.6 is equivalent to tell me. H is 0.1, right?
1.2
0.1 times 13.6 by 0.9 minus 1. Done. Alright? So can I go next slide? You can take the picture. Now I am going to find the value of V2 for V1. Anyone will do. Then, so this equation I substitute the value of this one in here. Okay? Then I can write. V2 square minus V1 square by 2G is equivalent to 0.1 times 13.6 by 0.9 minus 1. I wrote the same thing. So V2 square. What is V1 square? Do you remember? Do you remember?
1/3 square root.
Correct. What is V1?
Pass.
Pi by 4. D2, right? This one. This one I say D2. This one D1, right? This is A2, A1. And I substitute the value. Then pi by 4, D2 square, then square, right? D2 square, pi by 4, square, right? Times V2, then whole square.
What's the direction?
Equivalent to
What's mean get a
2GH, right? 2 times G is 9.8 times 0.1 times this value is equivalent to, can you calculate? I get here 14.11. Check. 14.11. Right? And here I cancel them. This value is 1000, this one is 300, right? Then I can write V2 square minus, this is D4, right? This one is D2 power 4, D1 power 4, V2 square, right? This one I get, I don't know what to write, right? 2.9.8 right? 0.1 right? 14.11. I don't want, you just do it by yourself. V2 square, right? 1 minus, this is 1 100 by 300 whole power 4, correct? 2 times 9.8, 0.1 plus 14.11, then V2 I get 5.29 meter per second. Okay? And what is the volumetric flow rate? The volumetric flow rate is Q2 is equivalent to A2 V2, right? What is A2? Pi by 4 times D square. D is 0.1, right? Meter square times 5.29. Unit is meter cube per second. Here you do not put 100, wrong. Here I put 100 because of millimeter, you can cancel. So if you put 0.1 and 0.3, you get the same result. Alright? So this is the answer. This is the volumetric flow rate for ideal flow. This is true for ideal flow, right? There is no friction. If there is no friction. Alright. So if there is friction, what to do? Flow rate is higher or lower?
Lower.
Lower, right? Because
Friction.
friction decrease the flow rate. So in that case, you have to show, no, not by I say it's lower. Okay? You cannot say this. Then in that case, you have to write down P1 by rho G, V1 square by 2G, Z1, P2 by rho G, V2 square by 2G, Z2, right? Some loss. You have to write down. Then you can write, what you can write? I am going to find the velocity. Then what I can write? I can write P1 minus P2 by rho G, correct? Plus Z1 minus Z2, all positive number, right? Then minus loss. Then V2 square minus V1 square by 2G. What we can see? We can see the value of V2 is lower. So from that concept, because of this loss, this is negative, right? If you compare with the previous equation, you can see, hence V2 for frictional effects, right, is lower than, right, V2 of ideal flow. That's all. You have to say something from the equation. Alright, so I am going to the last question, right? The last question is, hope that it is easy for you. The last question. So this one is estimate the time required to fill. This is the basic understanding. Estimate the time required to fill with water in a cone-shaped container. As shown in this figure, filling rate is 76 liters per minute. Alright? You understand or not? Okay, you forget about this shape. You look here. You remember? This is mass flow rate at inlet. I show you before mass flow rate at outlet. And here is dm by dt. Yes or no? Yes, right? So, what I can write? Tell me. dm by dt is equivalent to m dot I minus m dot O. Yes? Good. So now, this is the structure. So fluid is coming, right? there is no output. So this one is 0. If you look at this picture, we can see there is no output. This is 0. Then I can write dm by dt is equivalent to m dot I. What is dm by dt? Can I write this way? Rho d total volume by dt can rho area rho q I. Same thing, right? Any difference? No. Good. Then rho I can cancel. Then I can write what I can write here. I can write dv by dt is equivalent to qi. Then I can write dv volume, right, is equivalent to qi dt. What is the value of qi? This is the qi, right? Qi is equivalent to, tell me, correct. Qi is equivalent to 76 liter per minute, right? Right, no problem. Then I have to convert liter to meter cube. So this should be 76 times 10 power minus 3 meter cube per minute. No problem. Okay, now I can do integration between volume and qi is constant, right? So no need to integration dt, right? When time equals to 0, time 0. So what is the total volume of 0, right? There is no fluid. So the volume is 0 because of no water. Correct. When time becomes total time, it is filled with fluid. Correct. What is the fluid volume? The volume of the cone. That's all. Then I can write when time equals to 0, volume is 0. When time equals to total maximum, this is the volume of the cone. Right. Then after integration, I can write Vc becomes Qi times total time. Right. Then what is the value of Vc? Tell me. Vc is equivalent to volume of the cone, right? This value is equivalent to 1 over 3 r square h, right? 1 over 3 pi r square. R is 1.5 by 2. 1.5 by 2 r square h is 1.5. What is q? 76 times 10 power minus 3 times t. Now you can easily calculate the value of t, which is equivalent to 11.6 minutes. Understand? You have to solve this way. Sometimes I can tell you the volumetric flow rate is a function of time. Time. It depends on time. Time dependent. And some fluid also escape. In that case, you have to consider all cases. Right? If I make it complicated, can you take the picture? Done. Okay. If I make it complicated, for example, dm by dt and the I and the out, right? For example, is something like this. This is the structure, fluid is coming and fluid is, right? And something like this, and it is something like this. Then they tell you how the volume change, right? Or time, what is the time to deform whatever, right? This is Q becomes is a function of time, and this is something like constant value, for example. Then in that case you have to do this way. Rho is constant, same rho, so you can write dP by dt is equivalent to AIBI. This is Q, right? A out, B out. Then you can write this Q is a function of time. For example, they say this value is equivalent to A0, A1t, A2t square, whatever law. They can put complicated equations. Then you can write dV is equivalent to A0, A1t, A2t square, right? Times dt, right? Minus this is some constant number. So this one they put some 5, whatever. 5 dt. Okay? And they can tell you, this is coming, this is going, right? They can tell you after that equivalent equation. Correct. When time equals to 0, they can tell you, oh, it is fully filled with, the volume. The maximum volume, right? They can give you the number. Sorry, this is the time. This is the maximum volume, right? Time 0. And here also time 0. Because here is more, here is less. In that case, the volume decreases. Correct. If this is higher, this is lower, so this is something like that. So you have to understand the opinion. So from that condition, so outlet is here, right? Volume is here, maximum time. Here, maximum time, right? From that concept, this value should be given. From that concept, all these coefficients should be given. Then you can find. Okay? So this may be a complex situation. Okay, you have to understand. Okay? This will be one few. Alright? And you try to solve the previous year question for better understanding.